Good morning. Today we are going to discuss an important topic from your first module of Design and Engineering paper. Your first module of Design and Engineering paper includes these topics, of which Introduction to Design and Engineering Design were discussed in the last lecture. Today, we are going to discuss the second topic, defining a design process. The engineering design process is a series of steps performed in a sequence to create a product. The phases of design may vary from author to author, and the most common phases of design are dealt in detail with the help of an example. Imagine you are working in a company that makes diverse consumer projects and your boss calls you into her office and says, design a safe ladder. You wonder to yourself, why does anyone need still another ladder? Aren't there a lot of safe ladders already on the market? And what does she mean by a safe ladder? It's not a big surprise that a whole bunch of questions immediately come to your mind. Typically, design projects start with a statement that talks about a client's intentions or goals, the design's form or shape, its purpose or function, and perhaps something about legal requirements. That statement then leads to the designer's first task to clarify what the client wants in order to translate those wishes into meaningful objectives, constraints, and functions. This clarification task proceeds as the designer asks the client to be more precise about what she really wants. Asking questions is an integral part of the design process. Aristotle noted long ago that knowledge resides in the questions that can be asked and the answers that can be provided. By looking at the kinds of questions that we can ask, we can articulate the design process as a series of design tasks. For example, with regard to designing a safe ladder, we establish a client's objectives when we ask questions such as, why do you want another ladder? How will the ladder be used? What market are we targeting? After that, identify the constraints that govern the design with questions such as, what does safe mean? What is the most you are willing to spend? After identifying the constraints, you need to establish functions that the design must perform and suggest means by which those functions can be performed with questions such as, can the ladder lean against a supporting surface? Must the ladder support someone carrying something? After that, establish specification for the design with questions such as, how much weight should a ladder support? How high should someone on the ladder be able to reach? And after establishing the specification, you need to generate design alternatives with questions such as, could the ladder be a step ladder or an extension ladder? Could the ladder be made of wood, aluminum, or fiberglass? After generating design alternatives, you need to model and analyze the design with questions such as, what is the maximum stress in a step supporting the design load? How does the bending deflection of a loaded step vary with the material of which the step is made? So after analyzing the design, you need to test and evaluate the design with questions such as, can someone on the ladder reach the specified height? Does the ladder meet client's safety specifications? After testing and evaluating the design, you need to refine and optimize the design with questions such as, are there other ways to connect the steps? Or can the design be made with less material? So after optimization, you need to document the design process and communicate the completed design with questions such as what is justification for the design decisions that we have made? What information does the client need to fabricate the design? So, in short, these are the detailing process to meet customer requirements, of which we need to study setting design objectives, identifying constraints, establishing functions, generating design alternatives, and choosing a design in detail in this module. Okay. Now let's discuss about detailing customer requirements or framing customer requirements in detail. We focus on getting a clearer understanding of what the client requires because it helps us see lines along which a successful design might emerge. That is, we want to clarify what the client requires, account for the project stakeholders, and identify context within which our design will function. In so doing, we will be defining or framing the design problem clearly and realistically. As I have mentioned in the last slide, we talked about the role of questioning in the design process. A design team may ask questions of the clients and stakeholders who might have varying degrees of interest in the design, including potential users or experts in the field. The experts may be versed in relevant technology or knowledgeable about the market for which the design is aimed. Design teams may also hold their own internal discussions in which they ask each other questions to elect and list ideas that they can then organize into some problem relevant structure. It is important that such team discussion remain focused, particularly as they shift from the more general notion of overall design requirements towards the specifics of objectives, constraints, or function. The best outcome of this work is a list of attributes from which separate list of objectives, constraints, and functions can be extracted. Now let's discuss the design process in detail with the help of a design problem. Here is the problem. Malayali's craving for grated coconut is a stuff of legend. But grating coconut has turned out to be a tedious task for the very busy on-the-move nuclear families, leaving them to depend on packed products that are easily available in the market. There has been no change in the way coconut is grated for several decades. The only change being the introduction of a motorized blade, but still one has to hold the coconut. Currently available coconut scrapers in the market are time consuming, laborious, and are less safe as people need to hold the coconut near the blade. So here is your design problem. Design an innovative coconut grater which can do the job in just few minutes with improved safety and convenience. I repeat, your design problem is design an innovative coconut grater which can do the job in just few minutes with improved safety and convenience. Got it? While dealing with this design problem, you need to consider the following points. First, you need to identify the problem. So, in this example, your problem is coconut scrapers are time consuming, laborious, and are less safe as people need to hold the coconut near the blade. So, here the problem is available coconut scrapers are time consuming, one, laborious, and less safe to people. Okay, so here is the problem identification. And the second point you need to consider is the problem definition, or you need to define the problem. An innovative coconut scraper which is more safe, quick and easy to grade is to be designed. So you need to design a new coconut scraper with quick and easy to grade and it is more safe. Okay. Then next point, you need to set the design objectives. The design objectives are your design should be safe, it should be usable, it should be portable, affordable and user friendly. After setting design objectives, you need to consider the design function. The design function, you all know, the scraper should grade the coconut in an efficient manner. Okay. After design function, you need to consider the design means, whether your coconut scraper work on electricity, motors, blades, etc. After that, you need to consider the design constraints. What are the design constraints in this problem? Should it consume less space, less energy and have less weight? These are the functional constraints. And the second, operation of the machinery should be safe for the people involved. Includes the safety constraints. And the production of components, purchase of components, assembly, transport, process, etc. to be taken care of. Includes the manufacturing constraints, should be cost effective, which includes the economic constraints, should save time for the persons involved with, includes the time constraints, etc. After considering design constraints, you need to follow detailed design. The detailed design phase is the final phase in design process before manufacturing. The main goal of detailed design is to produce drawings that contain the information needed to manufacture the product. The detailed design of innovative coconut grating machine, its construction, parts used, working, etc. are described in detail in the detailed design. Okay, so in the detailed design, you need to explain or you need to design innovative coconut grating machine. You need to explain its construction. You need to explain the working of coconut grating machine. And finally, you need to suggest the design advantage of your innovative coconut grating machine. So the innovative coconut grating design is really time saving, less power consuming, safe and cost effective. It can grate coconut within seconds. The only power it consumes is for rotating the motor. Also it is portable and simple. The coconut will be scraped completely. The materials used for making these machines are safe and long lasting. So once you've given a problem, you need to follow these steps for solving that problem. Okay. Hope you understood these topics. Thank you.